Okay, so in section 3.1, we did measures of center, which was the mean, the median, and the mode. In section 3.2, so this assignment, we're going to be measures of variation. So it's not a measure of what the center of the data would look like, but it's going to be a measure of how spread out it looks. So let's just go ahead and start by taking a look at this picture. We have the white basketball team and the green basketball team. They may have the exact same center. In other words, their average height for all of their players on the white team and the average height for all the players on the green team might be the same. But if you look at the two teams, man, the green team is spread out a lot more than what the white team is. The white team here, if you look at all their heights, not too much of a difference between the smallest person, number 22, and the tallest person, number 42. But if you look at the green team here, man, the difference between their smallest player, which is number 11, and their biggest player, number 14, that's a big difference. That's the spread. That's the variation in the data. And so that's what we're going to have measures of as far as when we talk about variance. How do they vary, or how spread out the data is? And so one of the things that we could do is we could simply look at the one that you guys have been using for a while, which is the range. That's a measure of how spread out the data is. And if we just take a look at the range, we find the range by taking the biggest person minus the smallest person. And so in the white team, the biggest person is 6'6", the smallest person would just be 6 feet. And so the range would just be 6 inches. And then if we take a look at the green team, the biggest person is 7 foot, which is 84 inches. The smallest person is 5'7", which is 67 inches. And if we subtract those, what would that be? 17 inches, it looks like, which is over a foot. And so the range is a measure of how spread the data is. But it's not as reliable as what another measure would be, which would be the standard deviation. And so we're going to get to that here in a little bit. Real quickly, though, on the range is simply the maximum number minus the smallest number. Okay? And so let's take a look at the second measure of variation, which is called the standard deviation. It says the more variation that there is in the data, the larger is its standard deviation. And that's because the standard deviation is the average distance that every data point is from the mean. So it's better than the range because the range only looks at the highest number and the lowest number. The standard deviation looks at every single number and gives you an average distance away from the mean. So how do we calculate that? So we're going to have to do it in a unique way. Let's just take a look at these three sets of data points, set 1, 2, and 3. Set number 1 has a standard or has a mean of 7. Okay, so if this is 7 right here, we have all the points. The first one, the second one, the third one, the fourth one, the fifth one are all at 7. And so that's going to have a very low variation. The standard deviation is going to be very low. If we look at the data set number 2, and let's say we say this is 7, well, we'd have a point at 7, then we'd have another point at 6, and another point at 7, and another point at 7, and then one at 8. Well, the standard deviation is going to be a little bit bigger. Still going to be kind of close to the average. The average is still 7. The center is 7. But it's a little bit more spread out than the first data set. And then if we look at the third data set, we have one at 5, then we have one at 8, and we have one at 6, and we have one at 7, and then we have one at 9. So it's even more spread out than number 2. And so if we say the standard deviation is the average distance from the mean, what most people would do is just find the distance away from the mean. So they would use a formula that looks like this. And here's our summation. That means we're just going to add all of these terms together. And what this is saying is that we would just take each data point, subtract the average, which is 7. Like, for example, I would take 7 minus 7, which is 0. Here's the second 7 minus 7, which is 0. The third 7 minus 7 is another 0. I'd get a fourth 0 and a fifth 0. And I'm going to add those together. That's what the summation would mean. So if I add all those together, I get 0. And if I average them, I'm going to divide by the number of numbers that I have, which is 5. And so I'd have a standard deviation of 0. Well, if I do that same process with data set number 2 and I go 7 minus its average, I would get 0. And then I go 6 minus 7, well, that's negative 1. And then 7 minus 7 is 0, 7 minus 7 is 0, and then 8 minus 7 is positive 1. Well, if I were to add all these numbers together, I would also get 0. And if I divided it by 5, my average distance away from the mean would be 0. Well, that's not what I want it to be, because this is supposed to have a higher standard deviation, and the standard deviation would be the same as data set number 1. Well, I can do the same thing with the last set. If I take each of these points, 5 minus 7 is negative 2, 8 minus 7 is 1, 6 minus 7 is negative 1, 7 minus 7 is 0, and 9 minus 7 is 2. And if I add all these numbers together, again, I get 0. Divide by 5, and I would get 0. So we have a problem. This formula isn't going to work, but it's what most people would think that the standard deviation would be. So we've got to come up with a unique way for finding the standard deviation. So I want you to take a look at this formula here. This is actually one of the formulas that will work for finding the standard deviation, and I want to show you what it looks like just with these 3 simple data sets, and that would be the third one. So if I find the standard deviation with this formula, what it's asking me to do is this. Take each data point, which is x, and subtract the average. So again, here the average is 7. Okay, if I were to average all of these, my average would be 7. So I'm going to take each of these data points and subtract 7 and square the number. So for example, if I start with the first number, 7 minus 7 is 0. 0 squared is 0. I'll do the same thing with all of these 7s. I would get 5 zeros, and I would square all of those, and then I would add them together. So I'm squaring all the zeros, and then I'm adding them all together, but 0 squared is 0. If I add all those together, well, I still get 0. And if I divide it by the number of terms, that's what n represents. That's 5. 0 divided by 5, the standard deviation is 0. Well, that makes sense, because there is no deviation from the mean when they're all exactly what the mean is. Well, let's see how this formula affects the second data set. Again, my average is 7. But if I subtract the first number, 7 minus 7 is 0, and 0 squared is 0. Then I'm going to take 6 minus 7. Well, 6 minus 7 is negative 1, but negative 1 squared, well, that's 1. And then 7 minus 7, what I'm doing is I'm taking each number and I'm subtracting the average and then squaring it. So 7 minus 7 is 0, 0 squared is 0. This 7 minus 7 is 0, 0 squared is 0. Then I'm going to take 8 minus 7, which is 1, and 1 squared is 1. Then I'm going to add all those together. Well, now I get 2. If I divide that by 5, that's 0.4. And then I'm going to, because I squared all of these numbers, now I'm going to take the square root of this. The square root of 0.4 is 0.632. 0.632. So we would say that the standard deviation of the second data set is 0.632. That's not the normal way that we calculate an average, but it's the way we're going to calculate the standard deviation, or at least one of the ways. Let's see how this same formula works for the third data set. Again, the average is 7, and so I'm going to start with the first data point. 5 minus 7 is negative 2, but negative 2 squared is 4. So I'm subtracting it, and then I'm squaring that. Then 8 minus 7 is 1, but 1 squared is 1. 6 minus 7 is negative 1, but negative 1 squared is 1. 7 minus 7 is 0, 0 squared is 0. 9 minus 7 is 2, and 2 squared is 4. So now I'm going to add all of these together, and if I do, I get 10. I'm going to divide it by the number of terms, which is 5, and if I take 10 divided by 5, I get 2. And then if I take the square root of 2, I get something really close to 1.41. Which makes sense because it has a higher standard deviation than number 2, and it has an even higher standard deviation than number 1. So this is one way to calculate the standard deviation. I want to show you another way. This is the formula that we just used to calculate the standard deviation, but it's not the most popular formula to find the standard deviation. The most popular way to find the standard deviation is to use this formula. Let me show you how this formula works. Again, the average here for data set number 1 is 7. I'm going to do this first. I'm going to take each one of these x values, each one of these numbers here, and I'm just going to square all those numbers. So if I start with 7 and I square it, I get 49. And then I'm going to take the next number, 7 squared, and I get another 49. And I'm going to get 5 49s. And then I'm going to add those 49s together, okay, and divide by 5 49s. Well, if I add 5 49s together and divide by 5, I get exactly 49. Okay, that's what I did here when I was dividing it by the number of numbers. Well, then it says to subtract the average squared. Well, the average here is 7. So the average squared, that's also 49. Well, if I take 49 minus 49, that's 0. And then I'm going to take the square root of that, which is 0. So that makes sense because there is no standard deviation in the first data set. But let's see how this process works in data set number 2. Again, the average here is 7. But I'm not going to really start with doing anything with the 7. I'm just going to square all of these numbers individually. So in other words, I'm going to take 7 squared, which is 49. I'm going to take 6 squared is 36. 7 squared is another 49. Another 7 squared is another 49. And then 8 squared is 64. If I were to add all those numbers together, I would get 247. So that's what the sum of all of those squareds are. That's 247. And then I'm going to divide that by the number of numbers, which is 5. Well, if I take 247 divided by 5, I get 49.4. So then I'm going to subtract the average squared. Well, that's 49. 49.4 minus 49 is just 0.4. And if I take the square root of 0.4, I get 0.632. 0.632. If you remember right, this is the exact same number that we got using this formula on the previous slide. Most people just like doing this way better. I don't know if there's one that's better than another. It's just a different process. Let's see how this works in the third data set here. So again, I'm going to take each one of these numbers and square them. So 5 squared is 25. 8 squared is 64. 6 squared is 36. 7 squared is 49. 9 squared is 81. And if I add all those numbers together, I get 255. Then I'm going to divide by the number of numbers, which is 5. And if I do that, I get 51. Then I'm going to subtract the average squared. Well, that's 49, and I get 2. So if I take the square root of 2, it's 1.41. And that's what the standard deviation is for set 3. So those are two formulas that help us find the standard deviation. The number that I get when I square all of those numbers is called the variance. So in that second formula, the one right here, this number right here that I'm getting, like for example, the sum of the numbers squared here, that's 255. That's actually, is that correct? It says measure of how spread the data is from the mean. Okay, so the variance is what the number is before I square it. So like for example, here the variance was 2. Here the variance was 0.4. So sometimes you talk about the spread of the data in terms of the variance, and the variance is just the number that you get before you take the square root of the standard deviation. In other words, we could say the variance is the standard deviation squared. Okay, so it's the standard deviation squared. This is the exact same formula. I just don't have that square root sign above it. The stuff underneath the square root sign is the variance. Then the standard deviation is the square root of the variance. Okay, and we have that right here, the square root of the variance. And it would be the average of how each data point is from the mean. So that's a process that we could use, and we could write that formula down to find the standard deviation, or we could also do it by using our calculators. So at the end of this video, I will pull up a calculator and just show you how to do that with our calculators as well. Let's go ahead and talk about what's called the sample standard deviation. Sample standard deviation is almost exactly like the standard deviation, except it's only for a sample of the population, not the entire population. And there we use a different formula. And we could write this formula down, but I'm going to show you how to do this on your calculator so you don't have to. So if I find the sample standard deviation, that's going to be a little bit different than the standard deviation each time. And we can also use this formula to compute it. But let's take a look how this would work for this set of data here. If I have two data sets, and these are my two data sets, I have data set number 1. The X bar is the average. Okay, so the average of both of these data sets is 50. But if you look at data set number 1, these numbers are a lot closer to 50 than data set number 2, which means their standard deviation. Now this is a symbol for sample standard deviation. The sample standard deviation for set number 1 is 7.4. That means the average distance is 7.4 units away from 50. And then for data set number 2, the sample standard deviation is 14.2, which means these numbers here have an average distance away from the mean of 14.2. Well, how in the world do we get those? Well, we're going to get to that in a second. Let's take a look at this. There's a 3 standard deviation rule, which basically says, here's my standard deviation, okay, for both of those data sets. If I go 1, 2, 3 standard deviations above the mean in both data sets, okay, this is 1, 2, and 3, and then -1 standard deviation, 1, 2, and 3 standard deviations below the mean, almost always, all of the data points are within 3 standard deviations of the mean. Okay, that's true with anything that we're calculating. And so how do we do this with our calculators? And that's what I want to show you. That's what I want to show you next. So if you take out your calculators, and I'm going to go back to this slide right here, and I'm going to ask you to pull out your calculator. I'm going to show you how you can find the standard deviation of these data points using your calculator. We're going to start by going to Stat, and I'm going to click on Edit and Edit. And in list number 1, I'm going to enter these values. Okay, so I'm going to enter 41, and then 44, and then 45, and 47, and then another 47. So I'm right here. I'm at 48. Oops, let me go back here, clear that one. So I have to do my second 47, and then 48, and then 51, and then 53, and then 58, and then my final one of 66. So then we're going to go back to Stat, go over to Calculate. I'm going to do one variable stats. We've done this before because here's our average, 50. Okay, that makes sense here. Okay, we have the sum of all of the x values is 500. The sum of all of the x values squared, 25,494. And then I have these two values here. This is actually the 7.02 is the actual standard deviation of that entire population set. But if that's a sample of a bigger population, we would use the sample standard deviation, which is 7.4, and that's what they have marked here. So anyway, I would use, depending on the context of the question, most of the time we're going to use just the sigma x. That stands for the sample or the standard deviation of 7.02. The two formulas that we used earlier to calculate the standard deviation was this sigma x. That's the standard deviation. But if they ever talk about a sample standard deviation, that's what the S of x represents. And that's how we do the same thing on our calculator. So in this assignment, this lesson, we are talking about measures of variation. An easy way to do this is with the range, but probably a better way to find how far apart the data points are, how far they are away from the mean, would be to find the standard deviation. And there's a difference between the population standard deviation, which is what sigma x is, and the sample standard deviation, which is S of x. But both of them can be done on your calculator. So that formula that we used at the beginning of this video was just to kind of show you how to do it, but you won't really be asked to do it that way, even on a test, because you'll be able to use your calculator on a test in order to find the standard deviation. So hopefully this was helpful. There's a Math Excel homework assignment that you can work on, and we'll go over questions on that tomorrow in class.